All right, folks, in this video, I'm going to show you how to calculate a confidence interval with an unknown standard deviation. You don't know the population standard deviation. The best estimate that we have for that is going to be the sample standard deviation, obviously. So this is the problem that we're going to be doing, and I'm just going to do the first part. I'm going to create a 95% confidence interval around mean score. So what is our formula for confidence intervals when we don't know the standard deviation? Let's write that real quick. We have x bar plus or minus t alpha over 2, comma n minus 1. I put that a lot of times because that's the degrees of freedom of your for your student t distribution. Degrees of freedom are going to be very important for the separation. S divided by square root of n. So let's go ahead and start pulling out the things that we need from this problem. Sample of 263 students, so I know n equals 263. What about x bar? Did they give that to me? Yes, they did. The average score was 5.53. And the standard deviation of the sample was 0.92. S is 0.92. The only other thing I need is my alpha. And remember, alpha is going to be 1 minus the whatever confidence interval you're getting. So I'll just put confidence interval over here, 0.95. Now I have everything I need at my disposal to go back to my calculator, which in this case is going to be Microsoft Excel, and create a confidence interval. So let's start putting this in here. I need x bar, I need s, I need degrees, n, and the degrees of freedom. I sometimes put those in two different places, and sometimes I will actually just calculate the degrees of freedom myself later on. That's fine. So what else do I need? I need my t alpha over 2, but in order to get that, I'm going to put a place for my confidence interval, whatever number they give me for that. And then I'm going to put a place for 1 minus the confidence interval divided by 2. I'm making myself a template. It's going to be useful for any time I need to do a confidence interval around unknown standard deviation. Okay, and then t alpha over 2, comma n minus 1. I'm being very explicit about that. Okay, down here is where I'm going to put my lower and upper. All right, let's see. What do I got here? I got 5.53. I have 0.92. I have 263. And my degrees of freedom is equal to 263 minus 1. I know it's 262. I could hard code it in there. But I like making templates, so I'm going to go ahead and put that as n minus 1. I also like to highlight the stuff that I have to manually put into my formulas. This is another thing I'm going to have to manually put in it every time, is that 0.95. This one is going to equal 1 minus my confidence interval divided by 2, okay? 0.025. Now I can find my whatever that value is for my t alpha over 2, comma n minus 1. Now remember, Excel is not very smart. It's going to give you a negative number for this. We are going to coerce it into a positive number. T dot inverse our probability and whatever our degrees of freedom are. What does this represent? Drawing a picture very quickly. This represents the area under the curve for a t distribution. That this area is 0.025. This number here is 1.96. It's actually negative 1.96, but remember I put that negative number in front of it, so it turns it into a positive. I like dealing with positives when it comes to my confidence intervals. Now I have everything I need at my disposal for this confidence intervals. This equals x bar, this x bar here, minus t alpha over 2 times s over square root of n times s divided by square root of n. Okay. Now let's pull up the formulas mode so you can see all the formulas. As I do them, I'll give you the final output as we go. Equals x bar plus T alpha over 2, which is right here. If you're really good about designating what each of these things are, it makes it a lot easier to put these formulas together at the end. Times S divided by square root SQRT of n. I didn't put parentheses around here. I want to put them there. I want to make sure it does it in that order. Now I take a look and I say, okay, I am 95% confident that the true mean score of this test or whatever it was is between 5.4 and 5.6. Make yourself a template. It'll help you out a lot with these.